Good morning. This is Nathan Pierce from F5 Networks. I'm coming to you from Las Vegas. We are currently at the Gartner DC conference 2013. I'm here with Peter Silver. Peter, how are you doing, Peter?
I'm pretty good, Nathan. How you doing?
Excellent. This is a bit weird being the other side of the conversation here. So Peter is the author of DNS Intelligence Scale Reference Architecture. Peter, DNS. Why are we talking about DNS? Doesn't it just work?
Well, actually, DNS is quite important. You know, this year, DNS is celebrating its 30th birthday. So it was created back when the internet was created to translate the names we type into a browser into an IP address. And most of the time it does work. But we really don't think about DNS until it doesn't work, until you can't resolve something and you're standing there looking at sitting, clicking your browser, and it's just not coming up. And so most organizations don't really realize, I kind of equate it to, humans need air and water to survive, and in many ways, the internet, and particularly the web, needs DNS to survive if it wants any human interaction to happen.
That's interesting. First, that you're celebrating your joint birthday with DNS, being 30. This is good to know, mate. But also, how are people managing DNS? I mean, is it fairly robust? It's not something I think about, daily. Is it a complex thing to manage in the background? Is there a lot of room for failure there with DNS systems?
Actually, there is quite a bit of room for failure. If you look at the statistics over the last couple of years, DNS has grown 100% in the last 5 years. Internet actual, connectivity users has grown something in the percentage of like 220%. There are something in the range of 77 billion domain names out there, and another 6 million or so get added every quarter. And so you can see it just, continues to grow. And so with that, and then of course this, new insanity, the Internet of Things, upcoming, where various appliances, these home pieces are connected to the internet. I think the strain on DNS is going to continue to grow. Most organizations, DNS works just fine until there's a surge in traffic. Yep. There might be a media story, there might be an attack on their DNS systems, and that's when the DNS systems start to fall apart, because most DNS servers, those that are particularly running bind, which is typically in like 80% of the organizations out there, they can handle about maybe 200,000 requests per second. Anything after that, they start to slow down. And that can be bad, of course.
I imagine so. And
so when these surges happen, the organizations typically will just start chucking more servers, right? You throw more hardware at the problem and it fixes it, but that only works for that instance, and they might not need it during regular business hours. And so throwing money at it is really not the proper solution. Our solution is to essentially add the big IP, the platform, right there in the DMZ, and let big IP answer the DNS queries. And so essentially, the primary DNS server tells the big IP, you answer the question.
So this is solving both a scaling problem, but it's also a management. I don't know bind very well, but it's quite cumbersome to manage, isn't it? It's very susceptible to error at the configuration level. Is that about right?
Well, it's probably more susceptible if you think about it to, it's open source, so it's free. But there's certainly costs involved in the software and the hardware that it has to run on, the maintenance of the hardware. But it averages something in the range of about 9 patches a year. And so there are new vulnerabilities that are found that need to be patched, and so that's maintenance time and downtime potentially if you got to do that 9 times a year, rather than instead of having, like I said, have the big IP. And so that's the scale part, being able to scale. The big IP can handle something in the range of up to 10 million requests or response requests per second. So that's essentially. I did the math out for this, this massive number. What does it mean? People's head explode. It's basically 123 requests per day from every person on Earth is what our
That's
biggest,
significant.
is what our platform can handle. So that's the scale part. The intelligence part really is that context we often talk about. Understanding who the user is, where they're coming from, the type of device, the network, those sorts of things.
So not just blindly responding to a request wherever it is.
Right, making sure that the request is coming from the right location, they're getting directed to the right location, and then adding services like our IP intelligence service will essentially, it blocks all the bad networks that are out there. So they don't even make it to that point. The key about being in the DMZ is the fact that we answer all of those queries at the edge. We don't let them go all the way back to the primary DNS server and put the load on that. We just answer from the DMZ. You could even then add a DNS sec, secure DNS to it. So that chain of trust goes all the way back to top level, and there, an additional security mechanism built right in, on top of just protecting against DNS DOS attacks. And if you might not be aware, organizations like Network Solutions, Twitter, the New York Times, all of them have had DNS attacks this year, which brought their sites down.
Okay. So the high scaling is not just from legitimate business. Maybe you've launched a great new product and everyone wants to buy it, or it's a sales something. It's also from the security side, being able to scale is very important as well, isn't it?
Absolutely.
Because if you attack DNS first, it doesn't really matter how many servers you've got. They're invisible, aren't they, once that's gone?
Oh yeah, it's people think it's like if it doesn't resolve that, you're not going to get to it anyway. So it's one of the easiest ways, not easiest, but a pretty typical way to take out a site without necessarily going after the database, without necessarily going after personal identifiable information. Is essentially go after DNS and just make it unavailable. There used to be, I say this a lot, is we've always had protesters. Yeah. There are people who write letters. There are people who picket. There are people who throw rocks. With the advent of the internet, you don't have to necessarily go door to door anymore. Please boycott this company. Please boycott. So you can just wipe them, take them out, and then basically you got a worldwide boycott of this particular brand for,
And that's quite simple for people to do those attacks on DNS. Do they need masses of machines to attack, or is it something someone could do from their own home?
Yeah, you can. I mean, there are certain attacks you can certainly do on your own using things like the open resolvers that are available.
Is this the amplification attacks I heard about recently?
Attack, absolutely, yeah. Using those open resolvers out there to launch your attack, rather than necessarily infecting a botnet and having those launch all the DNS requests.
Okay, so this is really interesting. I mean, it's scale, because the Internet of Things, that's a massive increase. So, your DNS has got to run because you're blind after that. Yeah. And then the security side, those nasty people out there, they can wipe you out so simply. It's I guess DNS is more important. I've learned a lot today. Thank you, Peter.
And it's not just public websites. It's not just that your .com name that could be affected. DNS is critically important for internal. For internal resolution, for Exchange to work, you need DNS resolution. So just to get email, it's not just the .coms. It's also critically important on the inside.
So no DNS. We're back to pens and notepads then.
Yeah, or remembering dozens of number combinations to pretty much do anything.
Yeah, I can't remember the combination on my luggage, so I don't think I'd survive in that world. Okay, this has been really interesting. Thanks for chatting with us today, Peter.
Hey,
Again,
man.
This is weird being on the other side.
Nice job.
But thanks very much for listening. Bye.